Hello children, in today's class we will learn about the metallurgy and corrosion. So, in the previous 3 sessions you have learnt a lot about the properties, the physical and chemical properties of metals and non-metals, and in the previous class you learnt about the ionic compounds and their properties. Let us have a small recapitulation of what we learnt in the previous class. You know that atoms and elements either lose or gain electrons in order to obtain stable or octet configuration, and they become ions, and due to the attractive forces between the ions thus formed, ionic compounds are formed. This is what we learnt in the previous class. We also learnt the properties of ionic compounds, that is, all the ionic compounds dissolve in water, they have high melting and boiling points, and they conduct electricity in the molten state or the solution. And in today's class, let us learn about metallurgy and corrosion, the processes involved in metallurgy, what is corrosion and how you can stop corrosion. All of you know that the earth's crust is a major source of metals. Seawater also contains some soluble salts such as sodium chloride, magnesium chloride, etc. All of you know that sodium chloride is obtained from seawater. The elements or compounds which occur naturally in the earth's crust are known as minerals. Salts such as sodium chloride or magnesium chloride, all these are minerals. So, now you can see here, this is the earth's crust where you can find lot of minerals. Now, let us see what is metallurgy. Metallurgy is the process of obtaining or separating metals from the mineral or compound state they are found in the earth's crust. So, this is a process wherein you find minerals in the earth's crust. So, you have to separate. For example, the sodium chloride, what I stated, it has got sodium metal. So, separating sodium metal from the sodium chloride compound is a process of metallurgy. At some places, minerals contain very high percentage of a particular metal, and the metal can be profitably extracted from it. You can find minerals everywhere, but the percentage of that particular metal in that mineral should be so high that it can be profitably extracted. So, ores are the minerals which contain a high percentage of a particular metal from which the metal can be profitably extracted. That means, not much amount of money is wasted in that process. So, if you can profitably extract the metals from the minerals, such minerals are called as ores. You can see here, this is the platinum ore and that is the sulphide ore, that is the silver ore. You can see here there are various ores, lot of ores seen here, you can just go through them. So, we saw that there are so many ores, and these ores, based on their compositions, they are classified as oxide ores, sulphide ores and carbonate ores. Some metals are found in the earth's crust in the free state, some are found in the form of their compounds. On the basis of the reactivity, we can group the metals into 3 categories. One is the metals of low reactivity, metals of medium reactivity and metals of high reactivity. This you have already learnt in your reactivity series. So, there are certain metals which are highly reactive, there are certain metals which are not at all reactive, and there are certain metals which are moderately reactive. So, this is the reactivity series where you have the potassium which is the most reactive, and coming down you have silver which is least reactive, and there is gold and platinum which are not at all reactive. The metals at the bottom of this activity series are the least reactive. They are often found in the free state. For example, gold, silver, platinum, copper, etc. Though not copper, gold, silver and platinum, they generally exist in the free states. Metals at the top of the activity series like potassium, sodium, calcium, magnesium and aluminium, they are so reactive that you can never find them in the free state in nature. They are not found as free elements in the nature because they are very, very reactive. And metals in the middle of the activity series, for example, zinc, iron, lead, etc., they are moderately reactive. So, you find them in the form of compounds mainly as oxides, sulfides or carbonates in the earth's crust. Ores of many metals are oxides. This is because oxygen is a very reactive element and is very abundant on the earth. Now, we saw that there are different ores and we have to understand how to extract the metal from these ores. There are a lot of processes involved in the extraction of the pure metal from the ores. Ores are classified into metals of high reactivity, medium reactivity and metals of low reactivity. The metals of high reactivity have to be concentrated and purified by electrolysis of the molten ore, which gives the pure metal, and those of the medium reactivity, they exist as the carbonate ore or the sulfide ore, which has to be further processed, and metals of the low reactivity are found in the form of sulfide ores and other processes have to be continued. So, this is a mining site. Probably you could have seen this if you have visited any mine. So, they are extracting the ore from the earth. So, when they are extracting the ore from the earth, what happens? Lot of impurities are obtained along with the soil. So, you have to enrich the ores. So, what is enrichment of ores? It is the process of removing large amounts of impurities from the ores and increasing the amount of metal in the ore by employing suitable methods. And one such process is roasting. So, here what we do is we convert the ores into oxides by heating them strongly in the presence of excess of air. So, whatever impurities are present in the ore, the soil impurities, the physical impurities, they are removed, and from that also you have the oxides, the compounds. So, from that you have to separate the metals. So, for that the first process is you convert the ores into oxides. So, one process is by roasting, that is heating it strongly in the presence of excess of air. Another process is calcination. So, what is calcination? Calcination is converting ores into oxides by heating strongly in limited supply of air. So, if you limit the supply of air and then you heat it strongly, then it is called as calcination. And reduction. Reduction is the removal of the oxygen that may be present in the products obtained after roasting or calcination. During roasting or calcination, we actually convert the ore, the metal, into its oxide. So, now you have to remove the oxygen to get the metal. That process is called as reduction. Now, this is the reactivity series. In the reactivity series, you know which are the most reactive metal, which are the moderate reactive metals and which are the least reactive metals. The most reactive metals like the potassium, sodium, calcium, magnesium and aluminium, they have to be reduced by electrolysis, whereas zinc, iron, lead and copper, they can be reduced by using carbon. The others are generally found in the free states or the native state. Now, let us see how we can extract metals which are low in the activity series. One such metal is mercury. So, now one of the ore of mercury is cinnabar, mercuric sulfide, HGS. Now, we will study how we can extract mercury from cinnabar. Cinnabar is an ore of mercury. When it is heated in air, it is first converted into mercuric oxide, HgO. HGS is converted into HgO. This mercuric oxide is again heated and you get mercury, that is the metal. Now, we will see how we can extract metals which are in the middle of the activity series. One such metal is zinc, and we will study how we can extract zinc from zinc blend or zinc sulphide. The sulphide ore will be first converted into oxide by heating strongly in the presence of excess of air, that is roasting. So, the zinc sulphide is roasted with oxygen to form zinc oxide and sulphur dioxide is released. This zinc oxide is then reduced to zinc by using a suitable reducing agent such as carbon, coke. So, we use coke, which is a allotropic form of carbon, as a reducing agent. So, now when zinc oxide is heated with coke or reduced with coke, you get the metal zinc and carbon monoxide is evolved in the process. Highly reactive metals such as sodium, calcium, aluminium, they are used as reducing agents because they can displace metals of lower reactivity from their compounds. This you have already learnt in your reactivity series. You know that one metal which is reactive, then another metal can displace it from its solution. So, that you have already learned. So, using the same principle, we can use higher reactive metals such as sodium, calcium and aluminium as reducing agents to remove the metal from their metal compound. For example, when manganese dioxide is heated with aluminium powder, so you get manganese, and in the reactivity series when we observe, we know that aluminium is more reactive than manganese. So, now aluminium is displacing manganese from its manganese oxide compound. Reactivity series, you know that one metal which is reactive, then another metal can displace it from its solution. So, that you have already learned. So, using the same principle, we can use higher reactive metals such as sodium, calcium and aluminium as reducing agents to remove the metal from their metal compound. For example, when manganese dioxide is heated with aluminium powder, so you get manganese, and in the reactivity series when we observe, we know that aluminium is more reactive than manganese. So, now aluminium is displacing manganese from its manganese oxide compound. So, this displacement reaction is very exothermic, it is highly exothermic. So, the amount of heat evolved is so large that the metals are reproduced in the molten state. During this process, such a huge amount of heat is liberated that you can get the metals in the molten state. So, this process is called as Thermit process. The reaction of iron 3 oxide with aluminium is used to join railway tracks or craft machine parts. This reaction is known as Thermit reaction. So, this process is generally employed in repairing the railway tracks which are broken. So, now you can see here the Thermit process is used or employed in joining the damaged railway tracks. How we can extract metals from the top of the activity series, that means which are the most reactive metals. Carbon cannot reduce the oxides of sodium, magnesium, calcium, aluminium etc. to their respective metals because these are more reactive than the carbon, because these metals have more affinity for oxygen than carbon. So, these metals are obtained by electrolytic reduction. You have to reduce them by employing electrolysis process. For example, sodium, magnesium and calcium are obtained by the electrolysis of their molten chlorides. The metals are deposited at the cathode, that is the negatively charged electrode, whereas chlorine is liberated at the anode, which is the positively charged electrode. At the cathode, you have this reaction, sodium ion is obtaining one electron and it becomes sodium metal, and at the anode the chlorine will lose one electron. So, 2 chlorine will lose 2 electrons to become chlorine. Similarly, aluminium is also obtained by the electrolytic reduction of aluminium oxide. Now, let us see what we mean by refining of metals. So, we saw that various metals can be obtained by various reduction processes. Though different processes, we can obtain the metals by reducing from its oxides. But during this process, the metal that we obtain from this process is not very pure. They contain impurities, and this impurity must be removed to obtain the pure metals. So, to obtain this pure metal, the most widely used method for refining impure metals is electrolytic refining. Now, this is a setup, experimental setup, where you can perform electrolytic refining. So, you have a cathode, you have an anode, and you have a solution. So, when electricity is passed through that, generally it will be the solution of the metal that has to be refined. So, here it is an example of copper, and the solution that is taken is acidified copper sulfate solution. So, when you pass the electricity through that, so then you can see that the impure metal is taken as the anode and the pure metal will be taken as the cathode. So, as the process continues, you can see the impurities collecting at the bottom of the anode, and those are called as the anode impurities or the anode mud. The impure metal is made the anode, and a thin strip of the pure metal is made the cathode. A solution of the metal salt is used as an electrolyte, and in this process we used copper sulfate, acidified copper sulfate solution as the electrolyte. When electricity is passed through it, upon passing the electric current through the electrolyte, the pure metal from the anode, it dissolves into the electrolyte. An equivalent amount of pure metal from the electrolyte is deposited on the cathode. Now, the soluble impurities go into the solution, whereas the insoluble impurities, they settle down at the bottom of the anode, and they are known as anode mud, and they can be easily removed from that solution. Now, let us see how electrolytic refining of copper is performed. This process involves the electrolyte being acidified copper sulfate, and the anode is the impure copper, the cathode is the pure copper. On passing electric current, pure copper is deposited on the cathode. Now, we learnt about how the metals are obtained from the respective ores and how we can purify the metals. And after purifying the metals, we employ the metals for various uses. We use the metals for various purposes, but in the process, so in certain process, when we are using the metals may be subjected to what is called as corrosion. Now, let us see what is corrosion. You have observed silver articles. So, after you keep them for a long time without using it, exposing it to air, what happens? See here, you can see that the silver, this is the silver, and you can see that it has blackened. It has become black when exposed to air. You have observed this, and you have also seen this. Copper reacts with moist carbon dioxide in the air and slowly loses its brown shiny surface, and it gets a green coat. This is also one phenomenon that you have already seen. If there is a copper diya in your house, and then you would have lit it and you have left it for some time without using it, you would have observed that it develops a green surface. That green tinge, you find it in the diya, that copper diya. That is because of this process. It reacts with the carbon dioxide, the moist carbon dioxide in the air, and it forms a carbonate which is this green in color. And you have all seen this, experienced this. This is iron, but it is rusted. So, when iron is exposed to moist air for a long time, it acquires a coating of a brown flaky substance, and that is called as rust. This you have already seen, you would have experienced this also. So, this is a experimental setup where we will find out whether the iron rusts or not. So, we have taken 3 test tubes, we have introduced iron nails, and in one test tube we add water to half level, wherein the iron nails will be immersed only till the half of that, and air is present in the remaining part of the test tube. And in the second test tube we completely immerse the iron nail in water and we add a layer of oil over the water, and above that you have the air in the test tube. And in the third test tube there is no water and there is dry air, because we have added anhydrous calcium chloride, which is a drying agent which absorbs all the moisture from the test tube. Question is, you have to think and answer in which condition does the iron rust. Now, what is corrosion? Corrosion is the damage caused to the metal by the action of either oxygen or the carbon dioxide in the air. So, if we let the metal get exposed to corrosive action of these elements, then the metal will be lost. So, to avoid that, we have various methods to prevent the corrosion. Now, let us see one by one. Rusting of iron can be prevented by painting, oiling, greasing, galvanizing, chrome plating, anodizing, or by making it into alloys. Painting. So, painting is one very simple and usual method of preventing rusting to the iron. So, you would have all seen your classroom doors or the windows or the gates of your school or your houses, where all of them will be painted, and this painting is done to avoid the rusting of the iron. Another method is chrome plating. All of you would have, all of you enjoy using your cycles, right? And it has got a steel finish, and this is not steel, this is iron which is coated with chrome. So, during the electrolysis you saw that the copper, the pure copper is deposited on the cathode. So, similar process will be employed in chrome plating. So, wherein the metal, generally the iron metal will be coated with another metal, here chromium for example. Your chromium is plated on the iron so that it gets that finish and the iron inside will not be rusted. Another one is anodizing. This already you have learned that it is formation of an oxide layer, thick oxide layer of the metal over that metal again. So, this also prevents further corrosion. Another important and easy method is by making alloy. Alloy is a homogeneous mixture of a metal with one or more metals or non-metals. So, a homogeneous mixture of a metal with one or more metals or non-metals is called an alloy. Now, we have lot of advantages of making the metals into alloys. What are the advantages? We can obtain desired qualities, all desired qualities that we require. We can tailor make the qualities that we require by making them into alloys, and we can avoid rusting. We can harden the metal by making the metal into alloys. We can alter the properties of the metals. The electrical conductivity and melting point of an alloy is less than that of the pure metals. That is why we can use it to enhance the property, the electrical conductivity of the metal. For example, brass. All of you know brass. It is an alloy of copper and zinc, and bronze, all of you know the medals that we receive, that is an alloy of copper and tin. Generally, these two are not good conductors of electricity. Make use of copper in making electrical circuits, and also we use copper in electrical wires. But brass and bronze, they are not good conductors of electricity. though they contain copper metal in them. They are alloys of copper, but they are not good conductors of electricity. See here, this is brass and this is bronze. Both of them are not good conductors of electricity, though copper is very good conductor of electricity. And another alloy is solder. All of you have seen this soldering. So, lead and tin alloy, mixture of lead and tin, it is an alloy of lead and tin. It has got a very low melting point, and this is used to weld electrical wires together. So, when you have to connect two electrical wires together, they use solder. This is one of the most famous pillar near the Qutub Minar in Delhi. You know this Qutub Minar, which is in Delhi, and in this Qutub Minar there is one iron pillar. So, this was built more than 1600 years ago by the iron workers of India. They had developed a process which prevented iron from rusting. For its quality of rust resistant, it has been examined by scientists from all parts of the world, and the iron pillar that is present here is around 8 meter high and it weighs around 6,000 kgs. So, but even with this huge amount of material of iron present in it, it has not rusted till now. That is one advantage of making a metal into an alloy. Okay, now let us have a small recapitulation of what we learnt in today's class. All metals either occur in free state or the combined state. The process of separating metals from their ores and then subjecting them to refining further is called as metallurgy. Alloy is a homogeneous mixture of a metal with one or more metals or non-metals, and when the outer surface of metals like iron is exposed to moist air for a long time, corrosion is caused. And we also learnt certain ways and means by which we can stop corrosion. And now it is your assignment time. Which metal does not corrode? Think of a metal which does not corrode and write the advantages of making alloys. Right? Which of the following method is suitable for preventing an iron frying pan from rusting? Is it applying grease, or by applying paint, or by applying a coating of zinc, or doing all the above methods can we prevent iron frying pan from rusting? Think and answer. In the electrolytic refining of metal M, what would you take as the anode, the cathode and the electrolyte? This is a very important question. Questions like this may pop up in your exam. So, think and answer. In the electrolytic refining of a metal M, what would you take as the anode, the cathode and the electrolyte? Hope we will meet in another class. Till then, bye.